at understanding critical assets. I touch very basic point about it in the previous lectures, but we want to look in a more detail today, try understand why they are important to identify, how can we identify them, and possibly how can utilizing this understanding can help us mitigating cyber risk in some sense. What is asset management? So now we are talking about cyber physical systems. Yeah, we are talking about security of physical systems in a way. Physical systems are not new systems; they are there since very long time. Yeah. When we say asset, what is an asset? Any resource that we use part of a system, we call it an asset. Yeah. Asset could be devices. Asset could be your data, asset could be the people who are working here, and so on, right? So, in the typical or traditional physical systems, we have something called asset management. We wanted to understand the kind of asset, the types of asset we have, the number of assets we have, yeah, and how they are being used in our system. We also wanted to have, for example, some backup assets. When something goes wrong, we have a replacement, right, of those assets. So this is how you manage assets. Now, typically for physical systems, now physical parts obviously they have their life cycle. Similar to the software, hardware, most of the hardware having lower cycle in terms of years compared to softwares, right? For example, there is a software for IRCTC. It's there since very long. On the other hand, hardware devices, they have their own life. They require regular maintenance, right? And after a while, you have to discard them to get the new ones. So in physical system, we have a process called maintenance. The number of algorithms, techniques there, up to how many number of years you have to take care of those assets, and at what point you have to replace them. Now, IT systems are okay to buy or purchasing new because they don't cost much, right? For example, laptops, other devices. Servers cost a bit more, but other than that, most of the devices are reasonable. On the other hand, physical assets are really, some of the assets are really costly. And as we discussed, they are more customized in the sense they are manufactured by specific vendors, and running with underlying specific protocols in a specific data format and so on. So if according to your need, you have to order your items, setup, and it takes time to deliver because those devices, that setup needs to be developed, configured, tested, then it comes to you, then you configure, test it, train it, it takes time, right? Now, how do we understand this maintenance process? So everything is about time and cost, right? It's a very simple thing. If you need something urgently, you pay whatever it takes, right? If you have time, you can look at where is the minimum cost, and then accordingly you do things. Now, in a maintenance, every year companies pay a certain amount on maintenance, maintaining their assets, right, machineries and so on. Obviously, with the inflation, every year maintenance cost increases, right? And there is a cost to buy a new product, which also generally increases with inflation. But maintenance costs in most of the cases are much lower than the buying a new product. But at certain point, you see that maintenance cost is getting larger, larger and larger, because there are so many defaults, and faults in those machinery, in those assets. And we see that there's no reliability in the system. We can't really trust that this machinery is going to work, because we see every other day, every other week, there are some issues in that. So at some point, you decide when the maintenance cost is equal or greater than the buying a new item, you just go and replace the item. Yeah, you got the new one and replace it. So this is the typical model in maintenance term that we follow in physical world. Now we are talking about asset management, not just physical, but also cyber. Now when you bring cyber into it, what we wanted to know, the asset that we have, what kind of cyber issues they might have, what kind of cyber vulnerability they might have, right? What kind of cyber risk they might have that attacker can exploit to get into the system. So if we look at these are general kind of understanding around. If you look at the upper left figure, it says infrastructure, asset management, market size, 2023 to 2033. And if you carefully look at, it seems to be it's going to be double in 10 years. So in 2023, it was 37 billion US dollars, and that's going to be roughly 86. Yeah, so it's more than double in 10 years. Similarly, if you look at the other figure, which says cyber physical system market size 2024 to 2034, which seems to be again kind of at least double of a size. So we see in every 10 years, the market is growing. In every 10 years, roughly, as per this, there's a lot of scope in this market. And that's where companies, startups can get into this, right? If I ask you, whatever you have studied so far, if I ask you, think about a startup that you can offer, what it would be. Have you thought about it? So what are the different things you can offer? Maybe you can create a tool. Yeah? I can build a tool in Java, Python, whatever, and that can help me to either scan the network. Yeah? I can create a software for different systems that we have, for a university, library system, railway system, and so on and so forth, right? Or as a company, I can provide certain services. I can offer a company, I can offer a service for penetration testing. What is penetration testing? And what is ethical hacking? So there are two terms. One is hacking, one is called ethical hacking. Yeah? What's the difference? Yeah. So what is the good purpose like? Right. So generally, if I own a company and if I wanted to know what is the cyber issues I might have, I will hire a company that offers this service of penetration testing. I will invite them. They will look around whatever devices, assets I have, how many connections I have, what type of different network I have. And they will look and test every single device, network, and so to derive what are the issues in the system. What are the security issues in the system? And they will give you a detailed report so that you can take action on it. That's one thing. Apart from that, many companies offer some programs like bug bounty, fuzzy. Have you heard about this? Like Facebook, Google. They say if you can find any bug, any security issue in any of the products, report us. If that was true, we will pay you something. We'll give you some award. So these things are called ethical hacking. They believe that you are working for a good purpose, and since you have identified some of the issues, we want to recognize that with some token of appreciation. Yeah. On the other hand, you can find a bug and report it to the hacker. They can exploit it and then get it on the output. Yeah. So that is more negative things. Maybe you can get a lot more profit, but then that's not a good thing. We don't really kind of promote it. Cyber physical system market seems to be, it's going to be 15% on average annually. So the growth is 15% every year. What are the drivers of cyber physical market? Says growing trends of industrial automation. Now, whatever system we had in the past, most of the time we had humans that were working around things. We were having machinery that involves humans to operate, right? Then we got semi-automated machinery where you can write programs, you start, you pause, you stop, but then the rest of the thing done by program. Now we got a lot more automated programs. Yeah? Not just in terms of industrial, but you can also think of home automation, for example. Yeah? We have a smart kettle, right? We got, nowadays people are talking about something called food kit. I don't know what's the name it, but it's like if you program it, it will say at 7 a.m. I need a tea, at 10 a.m. I want something else, and so on and so forth. And you put all the ingredients there, it will prepare things as per your time and so on. Yeah? What we want machine to work as per our instructions. That's it. So that the human involvement is as low as possible. Yeah? At home is fine, but then in companies, if you're hiring someone, that means we need to pay salary to them, right? In India, salary is generally lower compared to other countries. In most of the Western countries, we pay, so there's something called minimum wages thing. You cannot hire anyone and you can't pay them less than what is the regulation says, right? You have to pay minimum certain amount describe, I mean every year they kind of derive it, what should be the minimum salary that you have to pay per hour. So what companies are doing, rather than I'm hiring 4 or 5 people, I can pay to a company that can automate things for me and I can save that cost. Yeah? That's one of the fears when people say AI is coming up, right? AI might do things that human cannot do even. It can replace humans, so cutting the job market. I'm not sure what will happen, but this is what people are thinking. They think, first of all, influencing machine is not possible. Influencing human is possible. Yeah? Human can make mistakes, but machine is very rare chance as long as your program is correct. There's no bugs. It will just behave based on the instruction of the code. Smart infrastructure development. So as we said, we wanted to build a smart world around us that looks really fancy. And in order to do so, we wanted to work around cyber physical systems, connecting more devices online, gathering more data, making better decisions and applying in different applications. Growing use of digital twin technology. What is digital twin? Have you heard this term? Digital twin. What is that? What is twin? So what people are doing, saying, so let's say there's a cyber security company and they're working on energy systems. They don't have access to energy system actually. Yeah? But they are the one leading cybersecurity firm. Because companies like power system company, they don't have cybersecurity expertise. And these are real systems. So you cannot just go there and plug in your laptop or your devices and start playing with the system. Yeah? No company will allow you to connect anything with their infrastructure. If you have to do anything, you have to do it in an isolated environment. You have to create your own environment and test it, rather than connecting to the real system. Because if anything goes wrong, it has a direct real-time impact. Yeah? So they won't take that risk. That's why they come up with something called digital twin. They say, can I replicate the hardware setting into kind of a software environment, in a digital environment? Yeah, so that's what is called digital twin. You're creating a twin of the physical system into a virtual environment. Like we have games. Yeah. Now there are so many games which can replicate the physical environment into. When you're playing game, it looks like you are doing the same thing. You're walking here, jumping, whatever. Yeah. In a similar way, we can replicate all the physical devices into the system, all the physical processes into the system with some logic. So it looks like the same environment where you can test it. You can mount an attack, see how it's behave. You put some control and test it and so on. So that's what companies are doing. And not just doing, they are selling it as well. Saying we have come up with a digital twin. If you want to test, here's the environment, you pay, use it. Yeah. What are the issues working on cyber physical system? Obviously, one thing is high implementation cost. Now we are talking about really complex system. It takes a lot of cost to build those. If you want to buy this kind of product, it costs you much more than a normal software. Secondly, shortage of skilled operators. So these are interdisciplinary topics. Yeah? As a person, you cannot have expertise of everything. So let's example of power system where you need people from electrical engineers. If we are talking about security, you need people from cybersecurity, right? Cybersecurity people might have limited knowledge about the power system, or the other way. Power system people have limited knowledge about cybersecurity. For example, an electric vehicle. It's an electric and vehicle. So it requires power, electrical engineer, it requires mechanical engineers, requires cybersecurity people altogether. Yeah? And that's where it says these kind of projects needs collaborations. There's a concept in software as well, we call it DevSecOps. Have you heard this? DevSecOps. What is that? So we believe that when we say software, we are talking about developers, right? People who develop those softwares. Now, if I want to look into security of those software, people who are developing software might not have understanding of cybersecurity. So I'm calling it DevSec. There should be a team where people from developers, cybersecurity experts sit together and then develop anything or test anything. Yeah? Now when I say DevSecOps, I'm talking about operational side as well. So in IT system, mostly there's no typical operational, but in physical system, we do have operations. I mean, IT also has, but they're not as kind of complex as we have in physical systems. So you need people who understand operational side of it, people who understand cybersecurity side of it, people who understand development side of it, right? How to gather requirements, what sort of security, how do you put. Now there's also something called security by design. Have you heard it? What is security by design? Now this term is very popular, which says if you are developing any product, any software, keep the security in your mind and include security aspect in all the phases of your software development life cycle. Earlier, what we used to be, security was not the primary concern. Rather, people were focusing on how you develop a software. Have you heard waterfall model, software development life cycle model? So there are a number of models, how you do this. So let's say you gather requirements, then you have design, implementation, and so on, right? And the model which says maybe you can't do the requirement, all the requirement in one go. As you iterate your process, as you develop your software, requirement might be on the add-on basis. Yeah. So we have models, sort of iterative models, where you kind of get the requirement, design those requirements, implement it, test it, but then add more requirement to it as it needs. Yeah. So there are a number of models. there. But when we talk about, because for example, these kind of system, when they built, there were no security at all. So there are protocol having a lot of vulnerabilities because they were not developed keeping security in mind. Their purpose was to start communications or start operations that they intended to. Now, since we are using them, connecting them on internet, looking around cyber aspect of it, now we are more concerned about security of these systems because they have very less security or very basic security, and anyone can exploit them. So we are more concerned into how to fix this. We need to develop the entire layer on the top of what we already have, because we can't build the system from the scratch. But the saying is, if you are developing new systems, keep the security in your mind, infuse it at every phase that you are doing in order to develop your software or systems. And that's the concept of security by design. When you're designing your system, think about security at that point of time, rather than building something and then say there are issues and then you go and fix it. If you're considering security when you're designing it, you will be having a much better product from cybersecurity point of view. So that's concepts of security by design. Oops. Okay. Now, so far we talk about cyber physical smart grid, for example, as an example, or electric vehicle. Now, in the future, what we are saying is we don't want to just rely on energy system that we have as of now, because, for example, oil, gas, coal, they are generating too much carbon emissions. Yeah. By the way, transportation sector is one of the key sector that generates largest carbon emission, and that's why government are pushing, saying we on more on electric vehicles, on less on petrol, gas. Yeah. But then if you are relying more on electric vehicles, that means you need more electricity. You're replacing petrol, diesel with electricity or energy. So there's a saying like we need to work around, solar panel based systems, wind turbine based systems, and others. Use more renewable energy sources, and then integrate them all together. Yeah. But the question is, when we integrate this, now, when we talk about one infrastructure, for example, smart grid, it's a country-wide infrastructure. It's already complex. Now, what we are saying, create new systems, integrate all together, so that we have much better energy, more integrated nature. Yeah, so we can supply it at local level, distributed manner, and so on. But from cybersecurity point of view, it becomes much, much complex. It will be much more complex. Now, we are just understanding what are power system devices, what their protocols, and so on. But then you have to then start studying what is solar panel, how solar panel technology works, how you create solar panels, how the communication takes place. And when you integrate with the whole system, any issues within those, that subsystem can influence your grid. Right? So in the future, it's good to in terms of thinking where we want to be. But in order to be there, it will take a while for us to think how to integrate things, what to care, and so on. Obviously, we are talking about scalable system and interconnected devices. So as I said, for example, electric vehicle or autonomous vehicle, they're already collecting some of the information from your vehicle. When you have autonomous vehicle, that means some of the information they also need to share with the other devices, or the people, or the environment. Yeah. One of the key things, as I said, we don't have enough expertise. Working people who understand cyber physical system security, but also when you integrate these systems, people or electrical engineer, let's say, who are well trained in electricity system, they might not be trained in solar panel system because it's a completely different technology. Yeah, completely different the way. energy is being generated. So then we need to have those people, but how will you create those people? So we need to offer training, the kind of programs where people can sit and learn those things. So what is situational awareness? So when I talk about large scale system, let's say if it is a typical IT system, what generally we do, we're sitting at one place. There's a network security engineer or analyst, or whatever you call it. They are the one who look at the traffic, right? What traffic is coming to this organization, what's going and so on. And then based on packet analysis, they got to see what is the threat. What packet seems to be malicious based on certain parameters, including, let's say, IP address, port numbers, payload size, and so on. Right? So we wanted to understand whether is there any threat to this organization, cyber threat. And if yes, then we believe most of the time it comes from networks. So you're capturing packets that are coming to the enterprise and want to scan it. So you have firewall that has certain rules. You said if any packet coming from this IP address or this domain, block it. Yeah, this could be malicious and so on. In this case, so in IT systems, it's not too complex in a way. Obviously, it depends on number of packets coming to your servers, but then it's manageable. When we talk about these complex systems, situational awareness itself is a complex term. So situational awareness is, if I'm working at control center and if I own, let's say I have 10 substations, I wanted to know what is happening in each of these substations. What happened? Right? Generally, how do we know? We are relying on data. So we are just waiting for RTU to send data in every half an hour. When it sends, I have a SCADA system. I'll pass all the data to it. I have certain power system algorithm that I run it and then see, this is what is. If it looks like there is a spike in a specific region in terms of demand, then you either increase the generation capacity or distribute load or whatever. Yeah? So you just manage that requirement. Yeah? So you are able to make those decisions, what to do once you have data, you pass it, you understand what's happening and what kind of instruction on an action you need to take to handle it. So that is what is called situational awareness. Right? Now what if you see there's an RTU which is disabled, it's not able to send any data? Then we have no idea what's going on. Power companies also do load predictions. So they have to prepare themselves. What will be the demand on average for tomorrow? And they will understand whether they are able to meet this demand. They have capacity or not. If next day or in a few days there's a festival, they know that there'll be huge demand. So they have to be prepared. They need to see if they can generate more electricity, energy, store energy, so that they can supply when it's required. Right? Compliance processes. So again, talking about specific type of system, there are different compliance requirements, more specific to country requirement as well. So in different countries, we have different compliance requirements. For example, if you're talking about healthcare, healthcare has something called HIPAA, HIPPA. If you say financial data, they have some PSI, DSS something. If you're collecting data, then we talk about GDPR, yeah? General Data Protection Regulations. So if you're collecting data, then you are bound to follow those regulations. If you don't do that, you could be penalized very hard. Now we are talking about this complex system where, since we don't understand most of these systems, it's very hard to meet those compliance requirements. Now, earlier we used to have those requirements in terms of physical systems. because they were physical systems, there was no smart systems. Now, since we have connected to internet, we are calling them cyber physical systems, so there are also cyber compliance requirements. If a company who is running, they're using those devices, then they are bound to follow certain cyber security regulations. They need to meet those compliance requirements. And these requirements will change from time to time, right? You have to have team who understand this. So now companies are also working on some kind of tools or some kind of software that can help them to understand whether they meet these compliance requirements or not. Yeah. And more importantly, when we say cyber risk, we are talking on in an IT system. It could be a process. There could be a process where we can evaluate the cyber risks, depending on the devices that we have. But in cyber physical system or an OT system, we have operational risk as well. So it's not just, as I said, it's not just data. It's not just you can hack a device. It's basically more risk for operation. No? Can it lead to disruption of the supply of electricity, for example? Can it create a blackout? Nobody has electricity for a few months. So they are more concerned about operational risk rather than just about the data. As I said, for physical system, even if your data is partially incorrect, it could be acceptable to the system as long as system is stable. But in IT system is not the case. So therefore, it's really, really important for us to understand cyber assets. So what are the assets there? Which one then are more prone to cyber attack? And are they critical to the enterprise, to us? Okay. So generally, asset management start with planning. Then you have planning, acquisitioning, operation, maintenance, decommissioning. Yeah? It's a kind of typical process that we follow in terms of physical asset management. Now, if we are talking about cyber physical, we also wanted to understand in each of these phases what could be the cyber risk associated to this process. Okay. Okay. When you have asset management, we also have something called resource mapping. Resource mapping simply says what assets I have, what operation and service I'm offering, and where they are involved in. In one operation, these assets are involved. In operation 2, other assets are involved, and so on. So you can get to see how these assets, what their role in an operation or service delivery, or the other way. If this operation is critical for us, what are the assets that are associated to this operation? So we need to be more careful around that environment compared to others. Yeah. Therefore, we need resource mapping. This can help us understand when each phase of this. For example, when you go for maintenance, we can understand if we go for maintenance, what are the operations that will impact. Right? Have you heard this term, asset discovery? Simply kind of a scanning. In IT system, we have certain scanning tool, right? Network scanning tool called, for example, Nmap. Have you heard Nmap? Nmap is a basic tool that you can run. So it gives you all the devices which are on the network. So you define the boundary of your network, you run it, and it will give you a list of how many servers you have got, how many workstations you have got, how many routers you have got, and so on. Now, the two types of asset discovery basically, one is active, one is passive. Passive discovery, you don't actively scan it. Rather, what you do, you look at logs, you look at the history, you look at simply scanning what are devices there, which is passive scanning without actively involving in the process. Second is the active discovery, where you scan the network, but also look at each of the devices and try understand with some experiment whether there could be is there any vulnerability in the system, right? So in IT system, is generally we do active discovery, because IT system can tolerate disruptions, right? Out of hours, you can always restart things. So typical penetration testing, when we say, we are talking about active discovery. So someone will come in, run the scans, find out how many devices you have got, how many connections you have got, and they will test each of those things and give you a detailed report what's going on here. Passive discovery we use in OT system, because OT system, as we said, it's real-time systems. You can't afford downtime there. That's where you can't apply active discovery. Because if you are testing a device and something goes wrong, it has a direct impact on the real system. That's why companies don't allow it. You just do passive scanning, do risk assessment, look at the whatever data that we have. And unfortunately, in OT system, you also don't have logs. Most of these devices don't have logs. Yeah, so you're relying on the measurements values, you're relying on the historical patterns, and so on and so forth. And obviously, what type of devices we have. What are the benefits of active asset discovery? It improves your security. You understand better about your devices and security aspect. Operational efficiency, cost reduction, compliance assurance, enhanced decision making. Yeah, so generally every year, this is a kind of suggestion. Every year, even the universities, I'm not sure here, but universities for example, in the UK, every year we do have penetration testing, where someone visit all the devices that we have within the universities, and they test it. Even when you bring your own device, you bring your own kettle, laptop, whatever, and they have a process where you go and then test it, whether is it in a good condition to be connected to the network, to the system that we have. Yeah, when they test it, they say, okay, you can use it. Then so it's a good way to manage the risk rather than being reactive. When something goes wrong, then you start reacting it. Kind of good to be proactive. Okay. Then you got change and configuration management. So automated discovery can also determine when devices join and leave the network, as well as when their configuration changes. Discovery tools continuously update asset database with these ongoing changes for strategic planning. Okay. Now there's a concept called software-defined networking. Yeah, have you heard this? Software-defined networking. Yeah, there's another called network virtualization, something. Yeah, what are these concepts? What they are doing? Right. So if I'm saying I have a hardware, I have a physical system where I got 10,000 devices. If any time that configuration changes in one of those devices, I need to go manually to each of those devices and change it in the hardware. Yeah? It takes time because we are talking about a large number of devices. So what they have started thinking, is it possible for me to create a software version of it? If I change within the software, run the command, it should be updated on every other device. So that is the concept of virtualizing things. Yeah? Software-based virtualization. So you kind of create a configuration system, make any change to this, and update system. When you update it, it will update all the devices. that we are talking about. So it's easy to handle it, first of all. Sitting at control center, one place, you can control the devices. But then again, it can bring a lot more other cybersecurity concerns, because someone who can control or have access to the software can control all the devices. So in physical system, we have configuration management. Whenever there's a, you need to change the configuration, bringing new device in, and there's a process in terms of. So maybe cybersecurity aspect of it seems to be better in terms of handling large number of devices, but then cybersecurity itself is an issue there that needs attention. We talk about cyber risk assessment already in a way. Vulnerability assessment. Once you know what assets you have, you would like to know what kind of vulnerability, active vulnerability they might have. So we have certain databases called CVE, which is publicly available, where people identify vulnerability, report it, and there's a database where you can look into, for this particular device, what are the different vulnerabilities that have been identified, how many of them already fixed, and so on. So in a way, you also want it to be connected, all your devices, with their database in a way, so that you can run scan every month or whatever in some interval to get to see whether devices that you are using have any vulnerability in the system. If yes, then obviously you need to take care of it. So it's a good practice to make it part of routine. So we talk about this, saying IT system mostly is easy to do, so we go for active scanning. OT system, we have more legacy system, proprietary system that doesn't fit all. We might have devices running different protocols, so they are very sensitive to what you can test. And since they're part of the real system, if anything goes wrong, it has direct impact on the systems. So we don't go for active scanning there, rather we just do passive scanning. Now these are the real challenges when we work on OT system. You can't have active scanning. So knowingly, unknowingly, intentionally, unintentionally, you are leaving some of the vulnerability in the system, because we can't test it, even if they are. Secondly, patch management. If you see there are vulnerability, you need to apply patches. Applying patches means takes time. You are updating the system. Updating the system might take time, first of all. Secondly, upgraded version might not supporting every other device or any other things. So how would you test that environment? So sometimes companies don't patch. Despite knowing that there are vulnerability in the system, they can't patch it. Because patching means additional level of testing and effort required to do this. So generally, IT system, we typically patch every month, every week, depending on how large organization, what's policy look like. But on OT system, generally it's once in every year. Okay. So that's what it says. I think I covered most of these things. So I'll skip this. Now, as I said, you can run scanning tool or discovery tool to get to know what are the assets you have. So you got a list of assets which are mostly on your networks. So routers, switches, gateways, devices, your laptops, and so on. Part of OT system, which there are devices which are connected to internet, for example, RTU, maybe IEDs, so they could be part of the network. So when you run scanning, you can detect them. But there are devices which are not on the network. A large number of devices which are not on the network from physical point of view. And when you run these asset discovery tools, they don't pop up in the list. So that's where we need to have a broad asset repository where you have a list of all the assets, physical assets, all the communication devices, all the other cyber assets. Out of this, we need to understand, now we are talking about a very large number. Yeah? We need to understand what are the critical assets, because we can't really pay attention to every other device. And we are more, and even system is under attack in cyber physical system, if it doesn't lead to a major impact, we can still manage things. So we are more interested to know what would be the scenario where a cyber attack can massively or adversely impact my system. That has a large impact, yeah, in terms of disruption, in terms of blackout, in terms of disabling devices, destroying devices, and so on. So there's a process in place, for example, say how to protect critical cyber assets. We talked about some of these points already. Develop a cyber security incident response plan, undertake cyber security exercise, undertake vulnerability assessments, establish consistent and sustainable security management controls, and minimize the risk against compromise that could lead to misoperation or instability in the grid. Okay. So what we do generally, so there's a guidelines by an ERC standard in the US. They say how you identify critical cyber assets. So the first step say identify a cyber asset associated with a critical asset. Group those assets. Determine which of these assets are essential to an enterprise. Identify cyber asset with quantifying connectivity, and compile the list of all the assets. So let's see how it works. So again, it's the same thing, what I said. Right, so it's a cyber asset that should be considered. First is control systems. Again, when we talk about these kind of cyber physical system, control system is one of the key things. These are the systems that controls the environment. Yeah? So possibly the devices which are part of control system are critical in nature by default. Yeah? You have a device that keeps voltage up and down, on and off, something is critical. What if someone has control over it? Right? So control system comprise devices and set of devices that acts, manage, commands, regulate behavioral processes. So smart grid or any other physical systems control processes, control systems, control things. Whatever decision is made by SCADA system, they have to take action on it, right? Turn off something, turn on something, increase something, decrease something. So we all do all these things by sending commands. You're sitting at control center, sending commands at remote substation, to increase some quantity, some decreasing something, turning on, turning off, and so on. So that's where they are really, really critical. What if someone else take control over it? Yeah? We got water treatment system where we put chlorine in it, yeah, to purify it. Now, mixing chlorine is not a problem, but what should be the quantity of chlorine should be there. What if someone increase the quantity? It becomes poison, right? So like in most of the Western countries, we got, and the people say you can drink water from tap, yeah? One of the reasons, because the government supply chlorine water. So they filter water, put some chlorine in a larger storage tank, and then supply to households. So you're getting the filter chlorine water, but then quantity of chlorine is really important there. What if someone take control and increase the quantity? It becomes poison and people will die. So it's really life-threatening. It could be life-threatening if you're just a bit careless. No cyber attack, maybe human mistake. Yeah? So the people who work there, who mix chlorine, they are the experts. They understand what they are doing. And there's always a record of those things. Right? For example, when you go to hospitals and when you ask for anesthesia, Yeah, certain procedures require that. They always has a logbook. They always has somebody which is witnessing what you are doing. Yeah, so it's not just the doctor. Someone, maybe another doctor will come and say, and he will show this particular injection, this much quantity, and then note it down somewhere, and then you put it. Despite considering they are the expert, they already know, but they don't want to take a chance. They have a process in place that always double check before doing things. Right? Data acquisition systems, different processes, part of system that helps us collecting data. So all the devices that are sensing, all the devices that are collecting, right? Communication channels that are sending data, and the server or system that collects data, process it, all part of it. Networking equipments, maybe routers, hub switches, firewall, modems. What's the difference between routers, hub switches? Have you heard repeater? What is repeater? What is hub? So where do we use it? Okay. So generally when we say hub, there are two types of hub. One is active hub, one is passive hub. Right? Passive hub simply work as a connector. You bring a passive hub and you connect number of devices, for example, for internet. The basic purpose give you connectivity through different ports, nothing else. Then you got active hub, which is called repeaters. Now the role of repeater is to amplify the signal. Now what does it mean, amplifying signal? Let's say what I want to create a local area network, LAN. What is LAN? If I have, let's say 10, 50 PC in this lab, I want to connect all the PC in a way, they all connected, they becomes a LAN, local area network. Right? I might have another lab, maybe downstairs or somewhere else, where I can have another LAN as well. Right? Now depending on if this space itself is too small, maybe we don't need repeaters. The cable length should be good enough to connect the other devices. But sometimes if we need to create a network environment in a larger area, the cable that we have might not be good enough. Now when we say cable, what happens? It's all about signals and signal strength. If a signal needs to travel farther, you need some devices that regenerate the signal before it lost. Right? So if I say if I'm generating signal at this point of time, my signal can travel from here to here easily. I'll put a repeater here. So even my signal strength goes down, it will amplify, again it will restart like this. So that's the basis of sending your signal from one end to other end, larger end. Yeah, but then local area network have their own restrictions how long you can have. Now there's another thing is called, it doesn't have here, bridges. So bridge is another networking device. What is the role of bridge? Connecting two LANs. Right? Switches, connecting two LANs also. Now switches comes with layer 2, layer 3 switches. What is routers? Sorry? So what's the difference between a switch and a router? Yeah, typically yes, but we also have now switches that works on layer 3. But the basic difference, switches gives you connectivity, connect two LANs, for example. Routers connect you with the external world. So for example, if I need to send a message from my computer here to a computer downstairs, do I need internet? Can I send without internet? The answer is yes. That's how we have intranet. Yeah, sometimes even if you don't have internet, internet should work. The reason is Internet operates on layer 2 protocols. Layer 3 is networking, where you need internet, IP, right? If you need to send a message from any computer from this organization to outside of this organization, you need IP address. Without internet, you won't be able to send it. And for that, you need routers. Routers are the one that creates a route for you, right? Creates a packet for you. So what happens when I'm, for example, if I'm connecting my laptop to this network internally, if I'm going to send an email from a person outside of the enterprise, right? What will happen? I will put, so in the packet, you need to put source address, destination address. So source address of this computer, IP address. Destination address, I know my friends, yeah, so it will automatically pick the address of that server, right? For example, Gmail, I want to send Gmail, so it will pick the Gmail, Google server, mail server, IP address, and it will send. Let's say I'm running a query, for example, rather than sending message. Now, since I'm running a query, I'm expecting a response back as well. Yeah, that's how it works. If I'm searching anything on Google and asking a response, asking an answer, what happens? So it's all about packets, in the form of packets. Since you are running a query outside of the organizations, so you need internet first of all. When we say internet, we are talking about layer 3 with the IP, right? Without IP, you can't do this. So when I search Google on this, I'm sending a packet from this system to the router of this organization. So generally, again, I'm not going to detail, but just give you a sense, every organization has a public IP address. Maybe you can Google what is the public IP address of an IT Hamirpur or any organization. They have one public IP address, which is assigned by, so they are regulatory bodies, they are centers around the world, depending upon which part of the region you are living. If you are in Asia, they have some organization. If you are a company, new company, and you want to connect, obviously you need one IP address, public IP address. Then you need to register to that body, whatever the process follow, and then get the IP address. And you put that IP address in your router. Internally, you don't need public IP address. So IP address has range of it. There are private, so some addresses reserved, they are called private IP address, which says every organization can use those private IP addresses internally. So for example, if you look at, I don't know if you can currently check what is the IP address of the device of your laptop. Most of the time it starts with 192.168 or 172, yeah, or 10.10 something. So there are couple of ranges that have been defined, saying any organization can use this range of IP address internally. So you can manage all the devices, whatever you have. You don't need public IP address. But if you're talking to external world, you need public IP address. Because the external world doesn't understand what is the IP address of this. If someone needs to send a message to this computer, they don't know what is the IP address, because it's a private IP address. It can change any time. So they will look at the IP address of this server of this organization, right? Router address, for example. So they will connect to the router. They know the public IP address, so they will connect to the router of this organization. And then router has a table, so they always maintain a routing table, which says I have sent a request from this computer to the external world. So router keep a mapping, saying there's a request coming from this private IP to a public IP externally. When you get a response, it looks into the table, saying there was a request from this system. Otherwise, if you don't have mapping, there's no way router would be able to deliver it to the correct PC, because it doesn't know which PC has requested it. That's why you maintain the table, because when you send a packet, that packet replaces sender address at router. So at router, before it forward message to the external world, it changes sender IP address from this local address to its public IP address. Because if you are sending this sender address, recipient doesn't know this address. They can't recognize this address. They only recognize public IP address. Yeah. So that's where we need routers if we want to send or communicate externally outside this organization. Okay, and then we go to hardware platforms. And generally, we have a practice to creating virtual environment using VMware and other thing. Right, so you can have virtual machine where you can, let's say if you're working on different operating systems, you can have virtual machines. One you can deploy Windows, Linux, and so on and so forth. So you look for all the hardware, you look for all the networking devices, you look for all the data acquisition system and control system. Yeah. All right, so let's have a break. Yeah? Let's have 10-minute break, and then we'll continue.